Okay, we're broadcasting. All right, so, yeah, I don't know, maybe here, I'm going to tell you exactly the number that kind of threw me on the homework and see if you guys can help me, like with the scatter chart, but maybe, and if you guys have ones that you want to go over, we can do that too. Okay, so, it was plot C on the individual homework on number 8.
Okay.
I think that was the only one I did not get.
So this was the one that he actually used for the example in the tutorial.
Oh, okay.
It's saying, so if you draw a line from the first dot, or say, actually, I think he took the second dot from the bottom to the last dot, you know?
Mm-hmm.
And then you can kind of see that the up and down from the line is very consistent. It's they're almost exactly the same. Doesn't matter which side of the line they're on, but they're almost the exact same distance from the line.
Okay.
And that would always be considered normal. And then the one under it would be the same thing. There are less above and, there are less that deviate from the line. But because it's really close to the line, it still would be considered normal.
Okay.
Like the difference would be, so like on A or E, if you were to draw the line, you know,
it's like way off. Okay.
Off. Yeah.
Okay.
Worst case scenario, if you're wondering, try and draw a line from maybe the first or the second or two, you know, first or second, and then the last one or the last one. And if it's pretty close to the line, then it's going to be normal.
Okay. Yeah, that really threw me. I was like, I don't know.
Yeah, I originally thought that C would be abnormal too because it snaked so much.
Right.
I thought it was going to be an S.
Okay.
No.
Okay, so what do you guys need to go over?
For me, I think it's just a matter of repetition.
Okay.
I understand. I know what the formulas are. I understand the concepts. I'm just still, I haven't done it enough to feel like I could
ready for it.
Right every single time something came, you know?
Yeah. What about you, Phil? Is there any problems or anything on the work that you had problems with?
Pretty much over and over and over again. Like, I get it, but I don't think I get it every time I do it.
Okay. Should we just go ahead and start the quiz then? Are you guys ready to do that?
Yep.
Okay. I'm going to get into it then.
Okay, me too.
Okay, homework.
Oh, I want to open that normal.
Okay. Group meeting.
Oh, that's one. Right?
What's that?
Oh, sorry. I'm already looking at the...
Okay. Are you guys into the quiz?
Yeah.
All right. Okay, the total area under the density curve must equal 1.
Yeah.
Wait, what? Hey,
So,
I do it.
Are you in the quiz?
Well, I thought I was, but I apparently clicked on the home.
Uh-oh. Well, don't get out of that. Just, yeah.
Open a new window. Go back to your main homepage portal.
Yeah.
And then open a completely new window.
Where is this?
So you basically just have to open up a new tab, but starting all over from your sign in.
Mm-hmm.
Is it in group meeting?
Yeah.
It's less than 5, isn't it?
Uh-huh, yeah.
That's what I did. Awesome.
Actually, this quiz looks pretty easy. I think we'll.
Do okay.
Yeah.
Okay, true. All right. The total area under the density curve must equal
1. Mm-hmm.
Perfect.
Okay.
All right.
Under certain circumstances, a density curve can drop below the x-axis. From what this says, it always lies on or above the horizontal axis, so false.
Yeah.
A normal density curve is symmetric, true. Okay, use the following image to answer questions 6 and 7. Okay, which of the following elements of the figure represents the z-score in this image? It's the C.
Yeah.
Wait, what?
Sorry, 6 is it's saying which of the following elements of the figure represents the z-score, and C. Yeah. Okay. Which of the following elements of the figure represents the probability that the random variable z will be greater than 1.000?
That's B.
That would be B, yeah. Okay, according to the 68, 95, 99.7 rule, what proportion of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? That'd be 68.
Wait. Where are you at?
I had that backwards. I was like, no, it's 99.7.
Yeah, 68 is 1, 95 is 2, and 99.7 is 3.
Yeah.
Okay, so it's 68, right? We don't have to put a percentage sign in there because it has it after.
Yeah, I already have.
Okay, suppose random variable z has a standard normal distribution. Use the normal applet, which I have up, so that's good, to answer this question. What proportion of the values from this random variable will be between -1 and 1?
Was it a 2? Wait, -1 and 1. Yeah.
Okay, so I'm sorry, what's the number we're supposed to be plugging into the normal applet?
Should be 1, right? Okay, because he says, what proportion of the values of this random variable will be between 1 and -1? So those are the z values, your -1 and 1.
Mm-hmm.
Decimal, 3-point decimal if your answer was, so it should be the same thing. Are they giving us the answer right there?
I don't know, I'm confused because...
Oh, it's 3-point, it's not. They didn't give us the right area.
Okay.
0.3173, is that what you got?
I don't know, because how are you calculating this? Because I don't see, like,
Well,
on the normal applet.
The values, our z values that they gave us are just 1 and -1. Or -1 and 1.
I see. Okay, so just put 1 in down there.
Yep.
Okay.
And then I'm getting 0.3173.
For, okay, hold on, I've got to go back to the test because I'm...
It's reasonable, so.
So it'd be just 317, right?
Yeah.
Is everybody getting the same thing?
Well, I'm going to make sure, but yeah, I think that's it. No, I'm not getting it. Okay, where on the normal probability applet, what are you guys doing?
So I'm putting under the z-score, I'm putting a 1. And
yes.
It both of them, right?
Right.
So then the area automatically calculated for you, and it's 0.3173 is what I got.
Okay, and you guys are doing it, you have what area shaded on it?
Oh, good point. So right now I just have both my ends, so we need to change that.
So it should be shaded between -1 and 1?
So it should be just in the middle section, right?
Yeah, I've got 0.6827.
For the normal standard use the applet, what portion of values will between the two numbers? Yeah, so it's 0.6827.
Okay. Okay. I was like, am I doing something wrong?
I forgot about the...
No, it's okay. I just wanted to make sure, because if you guys were shading another area and that was what it was supposed to be, I was just like, I'm not sure why I'm coming up with a different answer. Okay, 0.6827.
Oh, 0.683, right? Because we round to the third decimal.
Yeah, hold on.
Did you get that, Phil? So we were just shading. We didn't change the shading.
Oh, okay.
So it matched the question.
Okay, yeah.
We have to change it to between 1 and -1.
Yeah. It's not the two outside the inside, right?
I'm sorry, what was that?
It's not the two outside.
No, it's between.
Yeah, okay. So
It's
yeah,
not,
I got it.
yeah. Okay. 10. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2?
So it's the same thing, it's just 2s now.
Yeah.
0.955.
Yeah. 0.955. I hope we're doing this right, but I think it is.
It's right.
0.955. Okay. All right, suppose a random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between, so it's now -3 and 3. It'd be 97.7, but it's just the 68, 95, and 97 rule, but we'll go ahead and just plug it in.
Yeah.
Yeah, it's 99.7.
Or
0.997.
0.997, right?
0.997, yeah.
So yeah, it's the, look carefully, answer, plus what do you observe? It's the 68, 95, 97 rule.
On the number 10, would that make it 96 though, and not 95 because it's a 5?
No.
Let me plug it in.
We only go to 3 decimals.
Yeah, I know. I just was like, I hope we. I'm just like, if it was like 95, then that shouldn't be the right. I'm just gonna double check, make sure our rounding is good.
So it is 9545, and rounding it would make that.
Round it would be 955. Yeah, you're right. Okay. Okay, it says look carefully at your answers to the last 3 questions. What do you observe?
Yeah, it's the first one, right? 98,
The values match. Yeah.
Which one? The values match. Oh, you guys have different answers probably. The values match the 68, 95, 99.7 rule?
Yeah.
Okay. I have like it in a different order. Mine's like number 3 on the list. So. Okay. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirements will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good. Blah, blah, blah. Okay, so the population mean is 0.66, and And the population standard deviation is 0.07. So I'm going to write down that information because we're going to probably need it. It says, what proportion of the population have a protein requirement that is less than 0.60 grams? So what we need to do is take 0.60 minus 0.66 and divide it by 0.07 to get our z-score.
Where did you get the 0.60?
It says in 13, yeah, what requirement is less than 0.60 grams, and so 0.60 minus 0.66 divided by 0.07. I came up with a negative point. I don't know how far we go on this though. It's saying. Well, it's saying 3 decimals for the final answer, but we have to plug this into the normal probability thing. So I've got 0.85, negative 0.857. I'm just going to go that far.
That's what I've got.
And then I'm going to plug that into the normal probability thing.
Oh, for our z-score?
Yeah, 0.857. It's going to be, is it the less than or the more than? The question.
So what portion of the population required is less than?
So we shade just the area to the left.
Yeah, so it'd be that very first one, right?
Mm-hmm. Yeah. So it's, got the 2 red lines. It's going to be to the left, right?
Right. So
I come up with 0.19. It's 5.7, but you would round it up to a 6, right? 1.196.
That's what I got.
Did you guys get the same thing?
I did.
Okay. So 0.196. Okay, and it says what proportion of the population have a protein requirement that is more than 0.60? So we don't need to do a new z-score. We just need to go back to that normal probability thing and do
above
the negative side. So
wait, it's above 1 though, right?
Well, it's more than the z-score. So this is where I kind of got confused. But it's a negative. The z-score that we got is a negative. So if it's more than, you would shade the middle section and then the right section, I would think. And that's kind of what I found on the homework, but you guys tell me if you think it's different.
So if it's less than, does the opposite hold true then? Should we have done the middle and the left section?
No, because it's less than the negative, so your line is that left line from the center. Does that make sense?
I get it.
Yes, because the z-score on the left is your negative side, and the z-score on your right is the positive side. And so when we put in the z-score of negative 0.857, which is our z-score, the area to the left of that red line is going to be your less than, and the area to the right of it is going to be your more than.
That's what I understand. I understand that, but I get caught up. I'm hung up on when and when you don't put in that middle section.
Okay, maybe we should go to the homework. Maybe we should go to a homework that had a similar problem, because that's kind of what I found. Let's see. Go back to homework preparation assignment.
Norma, okay, so I'm at the Guyana woman.
Oh, are you you're in the homework?
I'm actually in the homework.
Okay, let me get to that.
2.2.1. So the area to the left. I don't know know if that one's going to help us too much, actually. Hold on.
So we need to find one with a negative z-score and see what it comes up with when you have to do more than.
There was one in the
Homework.
tutorials too.
Okay.
If you want to look for the one in the homework, I'll look for the one in the.
See, because like this one, like the z-score is 0.55 on baseball averages and 2.2. The baseball averages is 0.559, and it's saying the batting. They want the batting average that is above 0.280. And so you found the z-score 0.559, and then when you see on the little normal probability app, they shade only the area above that red line.
Right.
And then
then right under it they have a.
Well, that's between. Let's see. There's another. The above it. Let's see. It says the heights of the Ghanaian women, it gives a z-score of a positive 2.041. And it says, what proportion of young Ghanaian women reach a height that is at or below 169 centimeters? And so the z-score is 2.041, and then they shaded everything that is below that red positive line.
No fair, no fair. Now you get a big.
And as far as I could tell from the homework, if it's a negative, it's the same thing. It's like you go from that negative line
down, or the positive line up. Well, oh, because the other one would include some portion of negative. Or some portion of the positive. Okay, so let's look back at our homework. So we need where's my thing? A requirement that is less than 0.60. Well, see that includes a portion of the positive though. For the first.
Well, if it was. But the z-score is a negative, so it's just that, like you noticed on the batting averages, that positive z-score that they wanted more than, it didn't include any negative. It was only positive.
Well, I gotta think about what you said. So it didn't include.
Yeah, if you go back to the lesson and stuff, the positive z-score for the batting averages, where they wanted more the batting average that was higher than a certain amount, and you found the z-score and it was a positive z-score. If you notice, they shade only that top section, and it doesn't include negative. So I think the same holds true for like a negative z-score.
Yeah.
So I think the answer is going to be the 0.804.
Yeah, that would make sense.
I could be leading us astray. I'm sorry, Phil, what?
And that's for 14?
Yeah. I mean, I hope I'm not leading astray, but that's kind of what I gathered.
Yeah, no, it makes sense. I just wanted to double check because I'm confused about.
Well, we can come back to that one just to make sure, but I think that's.
So you got a 0.196
for the 13.
Oh wait, so for 14 would be greater than, so that would be 0.196 also.
It's 0.804. You shade the areas to the right of the negative z-score.
Oh, so that one would include the middle.
For the 14.
So 0.804.
It's pretty much everything that the other one's not. So if you look at those two numbers, they add up to 1.
Yes, that's right. Exactly.
Oh, okay, then now that makes sense because it does have to add up to 1.
Yeah.
As the What was that again? 0.804.
804. Yeah.
Okay. I gotta find my. There it is.
Thank you, Phil. Yeah, it is supposed to add up to 1, so.
Yeah, that makes sense. Okay.
Okay, so 15. What proportion of the population have a protein requirement that is less than 0.70 grams? Okay, so this is back to like question 13, but it's with a different number. So we have to take 0.70, 0.70 minus 0.66, and then divided by 0.07.
Yeah.
Okay. What do you get?
0.571.
Yeah, that's what I got. So that's our Z.
.571, and then we enter that normal probability, and it's not a negative, right? It's a positive. Okay, good. And
this is the lesson again. Then.
0.571. Okay, so we take everything to the left of the positive z-score. So everything except for that right section should be highlighted.
So we're doing the middle section too on this one?
Uh-huh, because it's less than.
Oh, wait.
But that's 0.78 or 78. Am I reading that right?
I'm sorry, what?
It should come out to 0.786.
Well,
I don't have that. I have 0.716.
I have 716 too, but why are we stating the middle section again?
Because it's less than the positive z-score, so it's everything to the left of that red line.
So then why didn't we do that on the question 13 then?
Because that was more than.
So on 13 it said.
Oh, because it's less than, and the z-score was a negative.
Oh.
On that, and so it was everything to the left of the negative z-score.
I got it.
I'm sorry.
This is the positive z-score. We have to include the middle. Okay, that makes sense.
Yeah.
Okay.
I know that really threw me off, and that's why I was paying close attention to it in the homework, to try to figure out how they were doing it, because I was getting those ones wrong too.
So it has to do with whether or not the z-score is positive or negative.
Yes, and that's which one we go by in shade. So.
Okay.
So I have for the probability applet that the area is shaded that would be less than the positive 0.571 z-score would be 0.716.
Yeah,
Perfect.
that's what I got.
Okay, is that good?
I figured out what I did wrong. I put the z-score up in the area. I don't know why.
Oh, okay.
So it just gave me a little bit different numbers, but yeah, I got it.
Okay, great. Okay, and then 16, which is the last question, find the probability that a randomly selected person will have a protein requirement that is between. Okay, so this is one of those that we have to find the z-score for both, but we already have them, right? So the z-score for 0.60 was what? Negative.
Yeah, so it's
Oh, well, but then you find the z-scores and then you find the averages and then you subtract. And so I think we just have to take the, it's between, but that might be different. Let me see. Okay, so let's shade them based on the z-score. So the 0.60 z-score was what number?
It was -857.
Negative 0.857. Okay, and then the 0.70 z-score is the negative. I mean, not negative. It's 0.571.
Yeah.
Okay, and we're trying to find the area in between, and so.
This one was easy.
I think we just subtract, but I want to make sure that the that it's kind of the above and below. Okay, let's see. So,
hold on. So in our homework, it will be similar to question. I know we did this, right?
So it's going to be above, so that's going to be a 0.716, and then below the z-score of point.
Yeah, subtract from the second answer. Great.
I think I've got it figured out. I'm just trying to plug in the numbers here.
Okay, hold on. Don't tell me what you get yet.
Okay.
Okay, area percent. Okay, I'm getting a do you have it, Phil?
I don't.
I do.
It's confusing me, so I'm learning here. I don't know what to do on this one.
Okay, so what did you get, and then I'll tell you what I got, and then we'll explain how we got them.
Okay, so this one you have to find the z-score for both, but you have to find it, you know, not just the z-score, but you have to plug those in, and then you have to find the areas below or above the negative or positive z-score. So we want to find the area above the z-score for the 6.60, and then we wanted to find the area below the area for the 0.70. So when you plug in negative 0.857 and you shape the area above, that gives 0.8043. And when you plug in the z-score of 0.571 and you find the area below, that gives a number of 0.716. And then you subtract the 0.716 from the 0.8043, and I come up with 0.088.
That's what I came up with. So
Good.
You understand how we're getting that? So
yeah,
you have to take
numbers in between those two, right?
you have to take the z-scores of the two different equations, you know, that we just got, plug them back into the applet. And the first one,
You're trying to get the probability that's above the negative z-score, so you shade those two sections in.
Okay.
And then that number is 0.8043.
Yeah.
And then you plug in the z-score for this 0.70, which is 0.571.
Mm-hmm.
And you're finding the z-score that's below that, because that's the high end. So you shade those two areas in, and that gives you a number of 0.716.
Okay.
And then you just subtract the lower from the higher.
Okay, so 0.088.
Yeah.
And that's the probability in between those two.
Yes.
Okay.
At least that's what I understood from the homework, and that's what you got too, Gina?
That's what I got too. Yeah, trying to figure out my notes. From the homework they give you on question E, they give you the solution, you know, the equation to figure it out, but it's kind of confusing to look at. So in my own notes, I just wrote, you take the area from the percent of the first value minus the area from the percent of the second value. That's a little easier for me to understand. And as long as you don't forget to take, you know, to shade the sections in between.
Sections, yes, yeah.
you're okay.
Yes. Because I was like about to take the other two, and then I'm like, wait a minute, if it's not, I don't know if we found the right sections, you know, the shading. So, yeah.
Yeah.
Okay.
Right,
well,
I'm pretty confident. I mean, from what I understand from the homework, I think we did them all correct.
I think so too. I'm always nervous though, because
we missed one. I got a 94.
Uh-oh.
It was the last one.
It was? Oh,
Yep.
Goodness.
Probability of the 7 minus.
6 to 0.
Oh, okay. It's not the 804 minus the 716.
Okay.
It's the 716 minus the 196.
196.
So instead of 14 minus 15, it's 15 minus 13.
Wait, you totally lost me. What?
So on the quiz questions, you know
Yeah.
how the answers we got for 13, 14, and 15 are all the probabilities and proportions and stuff?
Yeah.
So what we did is essentially we went 14, the 804, minus 15, the 716.
Yeah.
What we were supposed to do is the 716 of 15 minus the 196 of 13.
Oh.
Oh.
So the answer is 0.520.
Well, I thought the question answered between 0.60 and 0.70.
That's kind of what I thought too.
Okay,
But
let's for you read this carefully. So it says, Ryan or Birch.
I'm going to have to go over it with them because I feel like it should be more than 0.60.
Probably at the end, it's like, we'll have a approach requirement that is between 0.60
and 0.70, which would be
0 and 0.70. So 70, it definitely has to be between 0.60. Oh, that's because less than would be a negative. Wait a minute. No, that would be the case for 13, I would think. What proportion of the population?
It says, hint, remember that to find the area between two values, shade to the left of each z-score, you calculate, then subtract the smaller area from the larger area. Oh, I guess they gave us a hint, and I didn't read this. That would have been nice.
Okay, let me see if I'm still not catching, even though we know it's not right, I'm still not catching how it's not right.
I guess because you're taking the difference of what's less than, I guess, and subtracting it from. I don't know. I think that's one I'm going to have to ask Brother Bennett about.
either way, we still got a 94.
Yeah, that's not bad. I'm like, dang it. We're so close, but it's just that one little thing that threw us off.
I still not getting it there. Okay, so it's, yeah, let me just have to split up. Ah!
So why not? So my question to him would be, why not? Why is it that we took the less than? Why not the more than?
Yeah, because it makes sense to take less than and then the more. Well, it's because we're taking the less than on the 70.
Which is how we calculated. We calculated more than 60 and less than 70. Oh, I don't know. I'm so confused, but maybe they can. I mean, it says there in the parentheses that you take the left, but I'm not really sure why.
Me either.
Unless it's just because if you take more, then you have to factor all that stuff in. So, okay, well, we tried, y'all.
Yeah. We'll figure it out. I'll one of those that's probably, if I sit down and stare at it long enough, it'll probably make sense. But
Yeah, I'll definitely ask about it if I get on today, because I think that's, I'd like to understand the reasoning behind that so that it makes sense for the future.
Yeah, me too.
So.
Okay.
All right. Well, thank you, everybody.
All right. Well, thank you guys. We'll see y'all Tuesday.
Yeah.
All right. Bye-bye.
Bye.